All right, so it is Monday. It is 7 p.m. We are at the Milwaukee Makerspace, which means it's time to draw stuff and do this XC. So today is an advanced class. So I would like to play with making assemblies and using as-built joints. So we're going to make a scissor mechanism with an expanding and collapsing scissor mechanism. And we'll put a handle on one end and a little gripper of some sort on the other end, or a little mouth or something like that, a little T-Rex chomper. Yeah, so that's going to be our project for the next hour. I'm thinking we're going to make this all parametrically driven with parameters right from the start. So let's go ahead and start by making our parameters. So I'm going to click on Modify, and I'm going to scroll down to Change Parameters. So user parameters are things that we can specify about our drawing that make it really easy for us to change these specific things. So normally when we start making a square or a rectangle or whatever, we'd say, hey, make our rectangle 1 inch by 3 inches. But in this case, we could have a new user parameter that was like the height in inches, and that height could be like 6. We can even have a comment here if we wanted to. So this is the height of the rectangle. Hopefully that's how you spell rectangle. Otherwise I'll be embarrassed on the internet. So that's the height of our rectangle. And now when we go to make this rectangle, instead of typing in 6 inches, we'll type in height. And it will allow us to give us this parameter in a way that we can come back and change it really easy later without having to dive into our sketch. We can just come right to this window and change whatever we want to change and roll with it. Okay, so other user parameters we are going to need. The height, I'm imagining, as the initial height of the bounding box that we're going to draw our scissor mechanism in. So we'll also need a length. So the length that this scissor mechanism in its partially opened state we'll get to, because we're going to draw them as 45-degree angles just to make it easy, I think. And let's make the length like, I think it'll be 20, but it'll probably not be a round number because of how geometry works. So we'll start with 20 right now, and we can always make alterations later, or get close enough. Let's see. Let's also have a user parameter for like the size of our, like each of the little links in the link. Well, link. I was thinking link width. So the width of the link. You can't have spaces in a user parameter. So I use an underscore. But some people will choose to do it like this too, where they would. This is kind of like if you write code for a living, you're used to like writing the second word with a capital letter, and that makes it easier to read. But I like to use underscores because that makes it even easier. So the length width. Let's start by making it 1/2 inch. And just because this is kind of an obscure word, this is where comments come in handy. This is the size of each, I don't know, arm link? I don't even know what to call it. Words are hard. And then, you know what, let's also have one last user parameter, because it's a thing that I know I'm going to want to change later, is the size of the holes that we put in this thing. I'm just going to call it hole size. And I have a whole pile of M4 bolts. I know, shocking, because we use freedom units in this class. But the metric system exists literally everywhere else in the world. So we can use it sometimes. It'll be okay. As long as we're not doing things for NASA or we communicate our units really well. Yeah, hardware hole. Is it too soon to be making fun of NASA for their missed units? R.I.P. Rover. You know, yeah.
Just for the hell of it, you can leave your units in inches and write 4 millimeters as the expression.
That is interesting. That is a pro tip. Hold on.
It's
How do
not
I?
a pro tip. It's something I just tried and it worked. Because you type in 4 millimeters as the expression, units in inches, and the value is autocalc to 1.157.
All right. Cool. Awesome. All right. So I think that's all the user parameters that we are going to start with. We can always add more, but I think this is a good starting place. So I'm going to go ahead and click on the Oakley Dokley button.
What about the, you have the length of your link arm.
Mm-hmm.
What about the width of the link arm?
Well, that's not really the length of the link arm. That's kind of the, well, here, I'll show you. So let's start by drawing, creating a sketch. I suppose we could have drawn the length of the link arm, and then we could have had the number of links, because that could be interesting. That could be an interesting parameter to be able to change. I'm definitely changing my mind about how we were doing this. So the height, let's actually make that 4. Nope. I don't think we're going to use height. We're not even going to need that parameter, so I'm going to leave it at 6. We're going to use the length as the length of our link arm, and we're going to make that length like 4. And then I'm going to add another user parameter, because we can have a user parameter that has no units. And if our user parameter has no units, then we can use it when we're making our pattern, because we can do a pattern of these objects. And let's start with 4. Yeah, I think that will be a better way to do it. All right, cool. Because otherwise the length is really nondescript. I was going to draw like a bounding box and then draw X's in that bounding box, kind of. But I think this will be a better way to do it. Okay, cool. Thank you, Mike. So let's go ahead and say create. We're going to create a new sketch. I am going to draw on the front in my Fusion 360 environment here. And I'm going to start by making a line. I'm going to draw my line from the origin. So I'm going to click on the center point of my world there, and I'm going to draw my line up. And now is where we can use a user parameter. If I just type in L, it'll give me all of the user parameters that start with the letter L. And length is what I called the one I want. That is my 4-inch user parameter. And now I definitely, I think it's going to be easier on us in the long run if we start out this drawing by drawing these at a 45-degree angle. I think it'll just make the drawing easier to understand versus having some weird angle in there that we need to remember. So We're going to draw it at a 45-degree angle. Now, I'm going to go ahead and just click this little green X box there. I am going to draw the crossing piece here. Now, what I'd really like to do is I'd like to have a line that is exactly the same length at the opposite 45-degree angle that share the same midpoint. And it's going to be difficult for me to do that in one drawing, so we're going to draw it out of place, and then we're going to add in a constraint after the fact to put it into place. So I'm just going to draw a random line that is the right length of length, and then if I hit the Tab key, I can make it I don't even need to make it the right angle. I can make it the wrong angle. So that line is totally the wrong angle. But we can use constraints to put that line into place. So I'm going to start by adding, I think I'm going to need to add a point. So I need a point that is at the middle of our lines, both of our lines. So if I click on create and then come down to point, if I hover over the middle of each of my lines, or near the middle of each of my lines, I get that little blue triangle. That is our midpoint constraint there. So that is giving us that constraint. So this point is going to live right at the midpoint of that line. And I can do that same thing over on my other 45-degree line. I can add a point that exists right at the midpoint there. And that little triangle that appears next to that point is an indicator that there is a midpoint constraint that exists on that line. Now, I can add two more constraints. So from the constraints menu, I'll go and find the coincident constraint. And I will click on both of my midpoints. And now it'll add that coincident constraint, so they'll always be right on top of each other. So now we can add the last constraint that we need to add. So from constraints, I'm going to come down to perpendicular. So if I add this perpendicular constraint between my two lines, so I'll click on one line, and then I'll click on the other line, and then right into place. In theory,
computer crashed after we modified the parameter scale. I had to quickly try and recover it.
Should I pause for a second? I can pause for a second.
I think I got it.
All right, let's keep going. So now that we've got our X drawn here, now let's make our circles.
One thought, Carl. Okay, we know that we're at a 45 already, correct? Okay, how about if we go to the Create menu and grab Sketch Dimension and click on the happy little point of the first line and the happy little point of the second line.
Yeah.
And there is our number.
It is. But my hope is that because we want to draw this parametrically, my hope is we'll be able to later say, all right, my arm length is now 6 inches instead of 4, and it will automatically update our
Well,
pattern.
then you have to add another parameter, half of the length squared plus half of the length squared to square root.
Yeah, we'll cross that bridge when we come to it. All right, cool. So let's add some circles here. Let's add our holes. So I'm going to come up to the Create menu, choose Circle. I'm going to choose to make a center diameter circle here. And I'm going to make our hole size, holes that are the hole size, at each one of my 5 points here. So at the ends of each of my lines, I'm going to make a a hole-sized hole. And right in the middle, I'm also going to make a hole-sized hole, which is always the right size for a hole. Your hole should always be hole-sized. If your hole's not hole-sized, it's not a hole. That is a, if it's not a hole, it's a square? Yeah. I suppose a square hole is still a hole. It's just not a circular hole. Hole-sized. Lots of hole-sized holes.
Tautology night.
Tautology? All right, and then we are going to make 4 more circles. And these 4 more circles are going to be at the ends of each of our line segments here. And the circles that we're going to make, we'll also make center diameter circles. And those are going to be our, I think we call it link width. Yeah. So then we'll have circles that are the link width. And I'm just going to go ahead and make all 4 of these. And then I'm going to clean up my measurements a little bit, because I like to have nice, readable drawings. So when future me is looking at this, it doesn't swear at past me. I like it when future me does not think that past me is a complete idiot and makes more work for him in the future, when past me was totally capable of doing the job. I mean, future me is not used to it. Future me wants me to be better. And I support future me in the betterment of present me.
Elderly you will so
Yes, when elderly me has his reading glasses on, and is trying to figure out, because he can't bend over anymore, and he needs to use this scissor mechanism in order to pick up something. And he's like, oh, you know what? I need a 3D print one that's a little bit longer. He's going to need to look at this drawing again, I'm certain of it. So now we've got beautiful, beautiful drawings, and just for the sake of illustration, I'll show you why I wanted to use parameters here, because I'm indecisive, that's why. And now you can see that it's really easy for us to say, oh, I ran out of M4 bolts, now I've got M3s. And you change that parameter and all 4 of those numbers just magically change. Or I decide that future me decides that past me was stupid and 4 inches is way too short and they need to be 6. It's easy for me to just make that adjustment. Alright, so I'm going to do one more thing before we finish up this drawing. I'm going to change these lines to construction lines. Really the only purpose of them is to define a distance there. So if I click on them and hit the X button on my keyboard, then I'll change it to a dashed line, and that'll just make our extrusion later a little bit easier when we go to start extruding stuff. You can also click on the line, and then in the sketch palette there is a line type option, and I can change that line type to construction just by clicking on that little button, and we can change it to a construction line now. And now we just need to define the edges of our links. So from the Create menu here, I'm going to come up and grab the Line tool. You're in the Advanced class, so I'm going to show you a pro tip here. I want to make a line that is both tangent to this circle and tangent to this circle down here. If I hold down the shift button, the shift key, before I click, it is automatically forcing that to be tangent. So I'm holding down the shift button, and you can see that line is staying tangent to that circle regardless of where I move my mouse. And then if I move my mouse down to the other side, I can float over about the tangent, still holding down the shift key, and I can click, and now I've placed 2 tangents for the price of 1. And I didn't have to go up to my constraints menu at all. So hold down the shift key, click to place your line on that first circle, and it forces, I get that little blue tangent constraint. It's kind of popping up right there. And then I, while continuing to hold the shift key down, move my line down to the other spot and place the endpoint so it's also tangent down there.
Okay, I broke it. Why didn't it work?
Oh, the shift button doesn't work? Or?
Okay, I hold the shift, click line, hold the shift, click on the circle here, and when I try clicking on the circle
you
here.
gotta get it close.
Oh, okay.
Yeah,
All
there
right.
you go.
I was kind of taunting it.
Okay.
So that's not allowed then.
I mean, you're allowed to taunt it. It just may not do what you want it to do if you taunt it like that.
Okay.
You gotta be nice to your Fusion 360, and it will be nice to you.
Nice trip, thank you.
Yeah. And we will make all 4 of our lines in that same fashion. And I'm gonna leave these numbers up on the screen for a minute just in case anybody missed it. All good? Cool, cool. All right. So I'm going to go ahead and click on Finish Sketch. And now we've got a sketch to name. It's our favorite time of class when we get to name things. Because words are hard, I'm going to call this my link profile. You can call it whatever you want to. Anything is better than Sketch 1. I mean, Sketch 2 is not necessarily better than Sketch 1, but, you know, a little bit. All right, so at least you know it was the second one you made. So now, I am going to choose to, I think, extrude out these items. So I'm going to click on Create, and I'm going to come down to Extrude, and I'm going to extrude the entirety of one leg of my links. So one of those items, everything except for the holes in one of those items or one of those link sides, I think 1/4 of an inch is probably overkill, but I'm going to make it 1/4 of an inch anyway, because I'm pretty sure we can easily find 1/4 of inch material that I can cut on the laser. That'll be fairly rigid enough. And then I'm going to go ahead and click Oakley Dokley. So now I've got a body I can name, and we're going to call this Link 1. Link 1 is definitely better than Body 1, but not by a whole lot. And now I'm going to extrude out the other side. Yeah, 1/4 of an inch is definitely too much. I think 1/8 of an inch would have been plenty. In fact, that could have been a parameter. That probably should have been a parameter. You know what? It's not too late. It's not too late at all. In fact, if we come across something where we're like, hey, how come I didn't make a parameter for this? I already made an extrusion. It's kind of nice because parameters, when you make them in the future, you can use them in the past. So parameters are kind of like, I don't know, time independent or order of operations independent. So
Wibbly wobbly Timey-wimey.
Yeah, exactly. Time is a construct, man. So the name of this is going to be my material thickness. So the thickness of my material, I'm going to make it 1/8 of an inch. Because 1/4 of an inch is too thick for that, for something that small. And now that I have a parameter that I made here called material thickness, now this extrusion that I made down here in my timeline, I can right click on it and I can say edit feature. And now, even though I'm technically going back into the past, I can use as a distance my material thickness parameter. And there we go. I'm going to use that again. So I'm going to extrude out this other arm. And this time I'm going to have to go a negative material thickness because I don't have to go negative. That's so weird. Oh, it didn't take the negative. And so I have to go a negative material because I want it to go the opposite direction. I don't want them to exist inside of each other. I want to make an X where they could meet up and do a scissor mechanism. I also want to be sure that in this extrusion I am not joining these items together. In this operation here, we definitely want to make a new body. New body is good. And then I'm going to click OK. I'm going to name that new body link 2. And I'm going to come and see how you guys are doing on our click mechanism thing we're making. You got it? Cool. Cool.
I'm also calling mine front and back as far
Oh,
as the
yeah.
links go.
Front and back is also that would be a good way to, yeah, that's probably a better way. So if we call this front and this back.
Yeah, except that link 2 should be the front as you look at it.
Well, when we make our pattern, when we make a whole bunch of bodies, at least we'll be able to tell all the ones that are called front will all be the same angle, and all the ones that are called back will all be the same.
Mm-hmm.
It'll be like front 1, back 1. It'll kind of automatically name them like that. So that'll be handy for sure. All right, so now let's make our pattern. This is going to be the fun part where we get to do, or where I have to rely on the fact that other people in this room are smarter than me, and we'll do all our math together. It's gonna be just fine. Don't panic.
What? Are you sure that's possible?
It's definitely possible. It is more than possible. It is definitely true. So I'm making a rectangular pattern. And the objects that I'm making a rectangular pattern of are going to be my front and my back. And the axis that I'm going to make this rectangular pattern on is going to be this red axis down here. So it's whatever, if you want your axis to go up and down, you can totally do that too. But it's going to run perpendicular to the direction that we want our scissor mechanism to work in. And now I can drag this out here, and you see that I have a spacing. So my distribution type is set to spacing as opposed to extent. We already determined we have a user parameter for the number of our links. We called it number links. I called mine number links. So we're going to make it, the quantity is going to be whatever that is. And now the distance here, the distance is where we're going to do our math. So we want this distance to be relative to the size of our link. So if we do 0.5 times our length times our length I can't do it that way, huh? I can't do 0.5. Can I do? I can do our length times our length divided by 2. Why wouldn't you let me do this? What's your deal? Why are you swearing at me? Distance. Length.
I did it a different way.
Oh, yeah?
Yeah. Length, / left parentheses, SQRT, left parentheses, 2, right parentheses, and it worked.
So we do our length, and then
/ left parentheses.
I already have my left parentheses in there. Oh wait, I put my left parentheses first. SQRT.
Yes, and then another left parenthesis.
Yeah, it doesn't like that.
Well, you gotta finish
Keep
it.
going.
No, backspace 1. Now do another left parenthesis. And then 2. And then 2 right parentheses.
Another 2? 22?
No. 2, the number 2, and then a quantity 2 of right parentheses.
Hey, look at that. Neat. That's pretty cool. We're gonna check out your math on that. Mike, are you kind of getting that? So
I can't see it.
It's the length in parentheses divided by.
Okay, hang on. Let's.
Yeah. I wish I could zoom in on my screen, but that's not a thing, unfortunately.
Okay, length in parentheses.
And then divided by.
Divided by. Okay.
Yeah, divided by
Square root of 2.
square root of 2. And then 2 is in parentheses, and then that whole thing is in parentheses.
SQRT.
Yeah,
lowercase.
SQRT. Yeah, lowercase. And then the 2
Is 2 in parentheses?
Yeah, the 2 is in parentheses, and then that whole square root 2 is inside of another set of parentheses. So you need
And then an FX.
one more parentheses at the beginning of square. Nope, I'm lying. Length, open parentheses. I don't have FX.
Well, you have FX there next to your final parentheses.
That's not a thing that I typed though. That was like an automatic.
Okay.
Oh, that's an @ sign. We're missing. That's an @ sign, not a open parentheses. So there you go. There we go.
Okay.
But it's different.
Yep.
So your length is. Oh, you have instead of extent, choose spacing. Oh, and then you'll have to type it all again, unfortunately. Or here, change it back to extent ones. No, it's not gonna do it. Yeah, I thought for sure it would. Yeah, so if you change it to spacing, and then, yeah. Or you could just type in, that's totally fine too. That's totally fine too. So, now I'm curious if that really worked here. The way we can test that is by saying change parameters, and then we make our length, make the length of our thing like 8. Look at that. Maths are cool. Neat. Thank you.
Okay. Could you run that formula by me again? This time
Sure
I'll
can.
Try not to screw it up.
No worries. We're getting close here. So the last couple of things that I want to do here is I'd like to add, I want to do that now. Let's make our joints.
Say, let's make the handles now and the gripper now and make the joints next week. 'Cause there's a lot of stuff that can go wrong with this many joints.
I suppose. There's a lot of joints going on here. Tell you what, let's do this. I know what you were thinking when we started class. Carl, if we're going to make as-built joints, we're going to need more than one component. You are correct. And so I purposely did not do that until this point. So in this case, where you're going to have a whole bunch of components because you're going to have some joints, this is kind of my preferred method of doing it, is to make components from your bodies. So, because making a component is kind of it's a procedure, so you have to go up and click on create, and then make a new component, and then make your sketch inside of that component, and then you have to go up and click on create, and make a new component, and make another new component. Whereas this way, I can say, hey, I want to make a new component right now. In fact, I want to make a whole bunch of new components all at the same time. So I'll click on create, I'll click on new component, and instead of just making a new component called a name here, I'm going to make a new component from bodies. So I'll click on this little from bodies checkbox. And now I'm going to click on the body at the top of my bodies folder, my body list here. And if I hold the shift key down and click on the last body in my bodies folder, I will have selected all the bodies. This won't be parametric though. If we make more links, we'll need to come back and edit this and choose more. There's not a way for me to like choose all, is there? I'm curious. So instead of doing that, if I click on my bodies folder, I'm curious if it'll remember that I clicked on the folder called bodies and just choose all the bodies. So if there are new bodies in there, it might automatically add them. We'll find out later. But for now, this will work. So I'm going to click on all my bodies, and then I'm going to click on Oakley Dokley.
I clicked on the bodies folder and it automatically grabbed them.
Yeah. So now it made components from all of my bodies here. And now I can, on that first component there, this front one, this is going to be, I think where my handle is going to be on this side, and then my gripper or my jaws are going to be on the other side. So I'm going to click on the little active button component, active radio button on that component. And now when I choose to create a sketch, I can click on the surface of the face of this body. And when I make that sketch, it's going to make it inside of my front one component here. So now my sketches for this handle will live inside of this front one component. And I won't have to move things around later, and it'll be more convenient. And now I'm going to draw a handle of some sort. So let's see. We're going to start by, let's make the hand opening. I think I'm going to do this all with a spline. So I'm going to choose the fit point spline option. Yeah.
Quick question. I think my mind was wandering.
That's
When
okay.
you chose the surface, is it the inside surface or the outside surface? that you
It
chose?
doesn't really matter.
Okay.
Yeah, it doesn't really matter. So, I think it's the inside surface, but it doesn't really matter. We'll just need to know, you'll just need to be conscious of which surface you're drawing on when we go to extrude the object out. So you extrude it in the right direction. So I'm going to choose fit point spline, and I'm going to draw just kind of like out here in the middle, or in a vague middle of nowhere, a scissors-like hole opening. You know, if we had more time, this would probably be an occasion where I would bring in a picture of a scissors and draw on top of it. Have you ever done that before? Have you guys ever done that? We're not going to do it right now because it involves going off on a tangent. But I have done other recorded classes where we've attached canvases. And I'll let you go down that rabbit hole on your own, or look in past recordings for attaching a canvas, because it would be handy to have a shape of a handle that feels comfortable in your hand, that you know feels comfortable in your hand, and you test it and you like. And you could, you know, kind of trace that shape or modify that shape slightly, right? By attaching a canvas and then drawing around it, basically tracing around the lines there. But we're going to keep rolling like this. I'm going to draw a second spline around that. But first, I'm going to draw a line down here. So this is kind of going to be where my end of my handle grip is. And I'm going to make that line kind of extend out past it 1/8 of an inch on each side. And I'm going to finish the outside of my hand grip with another spline. And I'm just going to kind of freehand around the outside of our shape here. And then, oh hey, I keep wanting to hit the escape key. Like when I use the line tool, I can hit the escape key and it just kind of puts the tool away, which is convenient. But the spline tool, you actually have to click the little green checkbox. If you don't click that little green checkbox, your whole thing goes away, and then you're going to have a bad time. The nice thing about the spline tool is now after this I can drag these around until I get a shape that I'm pleased with. Because you want a ergonomic feeling hand grip. And again, you know, it might be nice to trace around a picture of something that you know feels comfortable. But I'm just going to kind of roll with it and eyeball it for now. And we'll see what happens. And once I've got mine drawn, I'm going to come and see how you guys are doing up yours. Oh, you're extruding already?
Yeah, I did something a little different. I used a double, right, I drew an ellipse, then I used a double offset.
Ah, cool,
An
yep.
offset to the
Mhm.
outside, then one to the inside, and I'm extruding it the material thickness, but I
Cool.
can't. What did we use for the
Uh,
parameter?
I believe, well, I called mine material
Link
thickness. That could be.
And that
Yeah,
would be
link
a
width.
join, correct?
I'm going to make this a new body.
Oh, okay.
Because I think these links I'm going to laser cut, and then the handle and the ends, I can 3D print those, and then just join them together. All right, so I'm going to click Finish Sketch, and now I'm going to extrude out my shape here. So I'm going to extrude it out two different directions. So instead of, because I like doing things all at once, why not? Instead of choosing to extrude this out in one side, I'm going to extrude it out two sides. And then in this side, I'm only going to go like 1/8 of an inch. Excuse me. And then in the other distance, I'm going to go my material thickness plus 1/8 of an inch. So that way what I end up doing here is, and I'm going to make a new body, I end up going 1/8 of an inch out from each face of my scissors here. Now I suppose another way that you could do this, just in the sake of eating up time that we don't have left in class, is instead of doing this two sides from a distance, you could also do this. Actually, would two object work here? I was thinking we could choose two object in each of these, and in this case the object is this side and it's offset from 1/8 of an inch. It doesn't like doing that for some reason. It would have to be from object, not to object, and we can't really choose from to object, so never mind, this does not work. So distance and distance, and then again this is material thickness. Why isn't that popping up? Material thickness plus 125. Now I'm going to say okay. So now we get a sketch we can name here. This is our hand grip. It would be nice, actually, in a scissors, the two sides are not symmetrical, so we probably should draw the second part, the second half. But for the sake of time, I am not going to draw that second half, like the thumb side of the thing. We can do that on our own. It's going to be just fine. What I do want to do is draw the gripper end. So let's make sure we draw our gripper end. In order to draw our gripper end, I'm going to find the appropriate component to draw that on. So the way that I find which component is which here is if I click on it in my drawing view, it'll highlight in my browser. So I know it's back 3:1. So if I make that my active component now I can do that same kind of procedure that I did, where I create a sketch, and I create that sketch on top of that link, and now I can draw whatever kind of gripper I want. The thing that I saw on the internet that made me want to do this, it was a T-Rex looking gripper. So I'm going to attempt to draw myself a little T-Rex gripper. So it's going to have a head, and then it's going to have a snout, and I'm just going to kind of freehand this in here right now, because give it some teethuses. You gotta have all the teeth. Probably this should be a mirror of the other side, but you know what? Maybe there is an argument for putting our joints in before we do the other half of this drawing. So if I make a chomping or a serrated edge here, it would be nice if my serrated edge could match up with the serrated edge on this side when they're closed. And for that to happen, I think I'd like to actuate it. So I'm just going to draw the one half of this as well. And then next week, we will pick up where we left off. I'm going to extrude this the same way that I extruded the other one. I'm going to extrude it two sides. One side is going to be 1/8 of an inch. I'll probably make a parameter for this as well. This 1/8 of an inch that I'm doing, and call it something, so it's something that I can change later. The other side is going to be our material thickness plus my 0.12 my 1/8 of an inch. Make that a new body. So we've got the beginnings of our little T-Rex chomper gripper thing. Or maybe yours isn't a T-Rex, maybe it's a pair of pincher fingers at the end. You can make whatever you want. I'm not here to judge. And next week, or the week after, because next week's technically a beginner class, so potentially the week after that, we'll pick up on this when we actually put joints in.
Okay. Next week is actually the 3rd, so it's holiday-ish.
Yeah, I will probably. I have off that day, and I'm not sure if I'm going to want to come and do a class. Mike, how you feel about next week? We'll see you next week. For those of you who are watching on video.